Dr. R.K. Radha, Assistant Professor, Department of Statistics, Presidency College, Chennai. She has done her PhD in statistics on a novel approach for prior selection in Bayesian modeling. She has 27 years of teaching experience, has guided 4 MPhil students, published 5 articles in national and international journals, has attended 10 conferences in India. She had given training for staff at Tamil Nadu State Statistical Training Institute, Department of Economics and Statistics.
Welcome to UGC lecture series on mathematical sciences. Today we are going to talk about statistical inference, under which we are going to discuss about methods of estimation. So today's topic under methods of estimations are method of least square estimation and method of minimum variance unbiased estimation. So to start with, let us discuss about method of least squares. So before going deep inside what is the method, let us discuss the principle of least squares. So the principle of least squares is used to fit a curve of the form y is equal to f of x theta 1 theta 2 etc. up to theta n, where theta I are unknown parameters to a set of n sample observations xi comma yi, I is equal to 1 2 3 etc. up to n from a bivariate population. This method consists in minimizing the sum of squares of residuals, that is E is equal to summation yi minus f of xi comma theta 1 theta 2 etc. up to theta n the whole squared, subject to the variations in theta 1 theta 2 etc. up to theta n. In general, the problem is to find out or to estimate the theta 1 theta 2 etc. up to theta n, which is given by dou ei by dou theta I equal to 0, I is equal to 1 to 3 etc. up to n. There are different methods in estimating the parameter, but in particular let us go to the procedure for fitting a straight line. So let us assume y is equal to a plus bx as a line of best fit. Now using the principle of least squares, as I have said earlier, least square is nothing but the method of minimizing the sum of squares. So here we are and to determine the parameters. Here we have two parameters a and b. So we have to determine these two parameters, which can be done by the equation E is equal to summation y minus a plus bx the whole squared. Minimizing the sum of squares of the residuals, we have this equation E is equal to summation y minus a plus bx the whole squared. Now I have said that to estimate the parameters a and b, we have to differentiate the equation number 1 partially with respect to a and b, that is dou e by dou a and put equal to 0. Similarly, dou e by dou b equal to 0 to get the estimators for a and b. Therefore, differentiating the equation number 1 partially with respect to a, it is nothing but twice of summation of y minus a minus bx into derivative of minus a is minus 1 equal to 0. Therefore, taking this 2 to the other side, it becomes 0, and multiply by minus 1, take summation inside. So you will have minus of summation y, minus and minus will become plus summation a plus b into summation x. Again, in the next equation, bring this to the other side. So it becomes summation of y. Now you are taking summation over a. So you have got n observations. So it becomes na. Then b into summation of x. So the required equation is nothing but na plus b into summation x plus equal to summation y. Again, differentiating the first equation with respect to b, let us see what happens. So it is equal to twice of summation y minus a minus bx into, you are differentiating with respect to b, so it becomes minus x. Now do two things, take this 2 to the other side and multiply by minus x, take summation inside. So here you will have minus of summation xy, then here minus and minus will become plus a, bring the summation inside. So, it becomes summation x. Then here minus into minus will become plus, then b into summation x squared equal to 0. So, take this particular equation to the other side. So, it becomes summation xy. Now, the terms which are left out is a into summation x plus b into summation x squared. Hence, you are getting the other equation as a into summation x plus b into summation x squared equal to summation xy. Now, fifth equation is one of the normal equation and the third equation is the other normal equations. So, equation 3 and 5 are called as a normal equation. Therefore, using this normal equation, you can find out what are the parameters a and b. You can fit in this equation, which will give you the line of best fit. Now, let us go through the first example. Fit a straight line trend to the data by the method of least squares for the given data table, and you have to estimate the sales for 1977. So, you are given year and you have been given the sales in lakhs of rupees. So, here we are going to fit a straight line. So, the straight line equation is nothing but y is equal to a plus bx. So, you have got the year, you have got the sales. Now, with the year you cannot do the calculation. So, you have to shift the origin. So, here the origin, see here how many observations are there, 1, 2, 3, 4, 5, 6, 7 and 8. So, if you want to fix the origin, you try to take the middle value, that is the middle of this. So, it is 1972.5 and you find the width is around 0.5. Hence, I have fixed my x is nothing but x minus 1972.5 divided by 0.5. So, my new year becomes minus 7, minus 5, minus 3, 1, minus 1, 1, 3, 5, 7 and 0, for which you calculate your x squared. So, simultaneously you will get 49, 25, 9, 1, 1, 9, 25, 49. Then you multiply x and y, you will get as minus 206, minus 200, minus 195, minus 72, 69, 180, 435 and 65. Get the total of y, get the total of x. Since you have taken the origin, the middle, you will naturally get summation x is equal to 0. Calculate what is called as 160 summation x squared, which is 168, summation xy is 616. Now, to estimate the parameters, your objective of the method of least square is to obtain the parameters. Here we have taken a equation of the form y is equal to a plus bx. Hence, your problem lies in finding out what are the values of a and b. So, to find out these values through the method of least squares, you have found out the two normal equations. So, these are the normal equations, na plus b into summation x equal to summation y, a into summation x plus b into summation x squared equal to summation xy. Now, in these two equations, whatever you have calculated from the tabular column, namely summation y, summation x squared, summation xy, you are going to substitute. So, on substituting these values, you get 8a plus summation x is 0, summation y is 526. Then here, since summation x is equal to 0, you will have 0, summation x squared is nothing but 168 into b 616. So, using these two equations, we are going to find out what are the values of a and b. So, a is nothing but 526 by 8, which gives you 65.75, b is nothing but 616 divided by 168, 3.66. Therefore, my trend line is y is equal to a plus bx. I have found out, estimated the values of a and b, which I have substituted. Now, my second problem is my x is nothing but x minus 1964.5 divided by 0.5. Okay. This equation gives you the line of best fit. Now let us go back to the problem. In the problem we have to estimate estimate the sales for 1977. So let us see what happens. So the estimated sales for the year 1977 is that you put x is equal to 1977 in equation number 1. So corresponding to that you find that here when you substitute here for 1977 you will have 3.66. So here y is nothing but a and this gives you b. So substitute you will get 98.69. Therefore, the estimated sales for the year 1977 is 98.69 lakhs of rupees, which solves your problem. Now let us go through the second problem. Explain the method of least square for fitting the curve of the type y is equal to a plus bx to a given data. So fit the curve to this following data. So here once again a problem lies in finding out a and b. So method of least squares, you know that already I have discussed that it consists in minimizing the sums of squares of deviations. Then you minimize that, you get two normal equations. Using the two normal equations, you try to solve the equation. So let us see how to work out this particular problem. So here the given curve is of the form y is equal to a b power x. Now for calculation purpose we are taking log to the base 10. So it becomes log y equal to log a plus, you know that log of b power x can be written as x log b. So to make our calculations more simpler, let us make the following transformation, namely that put y is equal to log y, x is equal to x, log a is equal to a, log b is equal to capital B. Therefore, the equation 1, here log y is nothing but y, again here log a is capital A, again log b is nothing but my capital B and my small x is nothing but capital B. So you find that this equation has been reduced from the curve, it has reduced to the line. Therefore, basic normal equation is that you take summation over the given equation. So it becomes summation y equal to na plus b into summation x, multiply the given equation by x. So you get the second normal equation, summation xy equal to a into summation x plus b into summation x squared. Solving these two equations, we get the best fit of a and b. So here given values of x, given values of y. So this column is nothing but take log of y. So on taking log of y, that is log of 8.2 to the base 10 gives you this particular value, namely 0.9138. So repeating the same operation for this column, you are getting the logarithmic values. Here I am replacing small x by capital X. So here the first column you will have the same values, that is 0.51, 1.5 to 2.5. Square it. So 0.5 the whole squared is nothing but 0.25, 1, 2.25, 4, 6.25. Then xy is nothing but product of these two. So that is 0.5 into this particular equation gives you 0.456907. Repeat the same operation to all these values. Get the total, that is here total of y is 6.94075, summation of x is 7.5, summation of x squared is 13.75, of course summation of xy is 11.37298. So here these are the values. So substitute the given values in the normal equations, that is in these two equations we are going to substitute whatever is the value we have obtained. So we are getting 5a plus b into 7.5 is equal to 6.94755, then a into 7.5 plus b into 13.75 equal to 11.37298. Solving these two equations, simple equation is how to solve this equation is that multiply this equation by 7.5 and then this equation by 5. You see to that a and a gets cancelled, you will get the value of b. Again multiply the first equation by 13.75, the second equation by 7.5, you will get the value of a. So, on solving these two equations, you get 0.81104 and b is nothing but 0.153896. But these are the values of the transformed variable. We have to come back to the original form. That is, a we have taken it as log a, b we have assumed as log b, y is equal to log y, x is equal to x. So, if you want this a, we have to take antilog of a. So, antilog of my capital A, which I have found out is 0.81104, antilog of this is this. Similarly, small b is nothing but antilog of capital B. My capital B is this, taking antilog 1.425. Hence, the line of best fit is 6.4720 into 1.42527. That is, I have estimated the parameter a, b cap the whole power x for the curve. Now, let us go to the next method, namely method of minimum variance unbiased estimates. Look into the procedure. If L is equal to product of f of xi comma theta is the likelihood function. Already I have discussed what is called as a likelihood function. It is nothing but the joint density function or product of the density functions. So, is the likelihood function of a random sample of n observations x1 etc. up to xn from a population with a probability function f of x comma theta. The problem is to find a statistic t, which is nothing but t is equal to t of x1 etc. up to xn such that expectation of t is equal to integral minus infinity to plus infinity t into L dx bar, which is equal to nu of theta, or I can write this equation as integral minus infinity to plus infinity t minus, take to the other side, t minus nu of theta L dx bar is equal to 0. Next is variance of t is nothing but integral minus infinity to plus infinity t minus e of t the whole squared L dx bar. Okay. So, whatever general form of variance of x is nothing but expectation of x minus x bar the whole squared, whatever it is. So, that is the, instead of x we have got t, x bar is nothing but expectation of x. Now, expectation of t through this equation is nu of theta. So, t minus nu of theta the whole square L dx bar has to be minimum. So, this is the method of minimum variance unbiased estimator. Now, I have used in this equation L dx bar. So, here I have taken likelihood function for n random samples. Therefore, my integral minus infinity to plus infinity dx bar represents n fold integration, that is minus infinity to plus infinity etc. for the samples dx1, dx2 etc. up to dxn. So, this dx bar is nothing but this thing. So, here what is the procedure is that we have to minimize equation 2 subject to the equation 1. So, let us see how to go about this particular concept of method of minimum variance through an example. So, let x1 etc. up to xn be a random sample from a Poisson population with a probability mass function P of r is equal to e power minus lambda, lambda power r by r factorial, where r takes the value 0, 1, 2, 3 etc. up to infinity. Now, I want to show my x bar is the minimum variance unbiased estimator of lambda. So, given the probability mass function my objective is to find out minimum variance unbiased estimator for lambda. So, we will go in parts to solve this particular problem. Let us go to the step 1. For Poisson population, you know that mean and variance is nothing but the parameter. Here the parameter I have considered is lambda. Lambda is a parameter. Therefore, mean and variance are lambda. See here, I have to utilize the method of minimum variance unbiased estimator. So, it says that first the estimator has to be unbiased, and for the unbiased estimator I have to find out the minimum variance. So, here first I have to show that x bar is an unbiased estimator of lambda. If it is so, then only I can go for the other step. So, you consider x bar, you know that x bar is nothing but the mean of n random samples x1 etc. up to xn divided by n. Take expectation on the either side. So, it becomes expectation of x bar, and you will have expectation of this whole lot of the equation. 1 by n is a constant, take 1 by n outside, then you will have expectation of x1 etc. up to xn. Expectation of the sum is sum of the expectation. So, you will have expectation of x1 etc. up to expectation of xn. You know that each mean is lambda. So, lambda plus lambda etc. up to lambda you will have for n random sample. Summing up you will have n lambda by lambda. So, lambda gets cancelled out, sorry, n and n will get cancelled out, leaving out lambda. Therefore, expectation of x bar is equal to lambda. Simple reason is that mean of Poisson distribution is nothing but your lambda. Therefore, you have declared x bar is an unbiased estimator of lambda. So, next let us go to the step 3. We have to find out variance of x bar. If x follows Poisson with the parameter lambda, you know that variance of x bar is nothing but variance of x is lambda. Now, I want to find out what is the variance of x bar. X bar I have said you can write it as 1 by n summation of xi. So, you have to take the variance of that. So, when you take the variance, you know that variance of a constant, say x by n is nothing but 1 by n squared of variance of x. So, here you will have n squared. So, you have taken here variance of summation xi. So, again summation of the variance is nothing, variance of summation is nothing but summation of the variance. So, you ended up namely that variance of x bar is equal to summation of variance of xi by n squared. As I have said earlier that mean and variance of Poisson distribution are the same, that is lambda, the parameter which I have considered here as lambda. Therefore, here you will have here summation of lambda by n squared. So, here for n observations you will have n lambda by n squared. So, striking out you will have lambda by n. Therefore, variance of x bar is equal to lambda by n. So, we have already said that mean is lambda and x bar mean of x bar is unbiased. Then we have found out what is called as variance of x bar. The last step is nothing but you have to find out the minimum variance. So, here to find the minimum variance I am making use of Kramarov equality, that is if an estimator is unbiased then variance will be equal to the this particular part, that is in other words you can consider the lower bound of the Kramarov inequality. So, let us take the minimum variance, so which is defined as 1 by n into expectation of dou by dou lambda log of p of r the whole squared. So, here your equation number 1 is nothing but e power minus lambda power r by r factorial. This is your equation number r. So, take log. So, when you take log, this is your P of R. So, when you take, you will have log P of R. Here when you take log, it becomes minus lambda plus here R log lambda. 1 by R factorial is nothing but minus of log R factorial. Now, according to this step, we have found out log P of R. Next, we have to differentiate partially with respect to lambda. So, on differentiating dou by dou lambda log P of R, when you differentiate, this becomes minus 1. This is nothing but, you know that log of lambda is 1 by lambda. So, it becomes R by lambda. So, here you take the LCM. When you take the LCM, it becomes minus lambda plus R by lambda, which I am writing it as R minus lambda by lambda. Next, it says that you square it, multiply by n and take expectation. So, n into expectation, my this particular term is nothing but R minus lambda by lambda the whole squared. So, you expand that particular term. When you expand here, it becomes R squared. This you use the basic expansion, namely R squared minus 2 lambda R plus lambda squared by lambda squared. Now, take expectation inside, because expectation of the sum is sum of the expectation. So, expectation of R squared minus 2, since lambda is a constant, expectation goes for R. Here it becomes expectation of lambda squared. Now, expectation of R squared is nothing but, you know that variance of x is expectation of x squared minus e of x the whole squared. Now, you have got e of R squared. So, you replace x by R, you will have variance of R, this goes to the other side, expectation of R the whole squared. Next here, minus 2 lambda e of R plus e of lambda squared. Again, lambda squared is a constant, so expectation of that is lambda squared. E of R, that is the mean of Poisson distribution, is lambda. Lambda into lambda gives you lambda squared. Here mean of lambda is lambda, so it becomes lambda squared. Variance of Poisson distribution is lambda. So, you got the terms. Now, you find that lambda squared and lambda squared adds up to 2 lambda squared, gets cancelled with this term, leaving out only lambda. So, you have got lambda. So, n by lambda squared of lambda is equal to n lambda. Therefore, you got the denominator part as n by lambda, but you said minimum variance is equal to 1 by this particular format. So, it becomes 1 divided by n by lambda, which is lambda by n. I have said that to get the minimum variance unbiased estimator, I am making use of Kramer-Rao lower bound. So, the Kramer-Rao lower bound is equal to the variance of the unbiased estimator. So, here I have got x bar is an unbiased estimator of lambda. So, variance of x bar is equal to 1 divided by n into this particular term, which I have said that this whole term is nothing but lambda by n. Already I have shown that variance of x bar is lambda by n. So, here lambda by n is equal to lambda by n, which is nothing but the Kramer-Rao lower bound is satisfied. Therefore, x bar is a minimum variance unbiased estimator of lambda, which proves your problem. So, remember that to show that for minimum variance unbiased estimator, it is a must that you have to show the estimator is unbiased and it is minimum. Now, coming to the summary, what we have discussed in this session, I have discussed two topics, namely method of least squares. So, that method consists of minimizing the sum of squares of residuals, and using the normal equations you can estimate the unknown parameters. Coming to the method of minimum variance unbiased estimator, I have said that to find out the estimator, it is must that the estimates should be unbiased and you have to show that it has got the minimum variance. Now I have got few questions for you to work out. First question is nothing but explain the method of least square estimation. Second, fit a straight line trend to the data by the method of least squares. So where I have given two columns, two rows, one for year and the other one is for the output. Using that you fit a straight line trend. Third one, explain the method of minimum variance unbiased estimation with an example. Thank you.